Hello, 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 guys. I think we're live. I think everything is working. Let me see that. Yep, it's fine. So today we're gonna talk about game development. Because Lydia said it's a good idea that we would do that. I'm not 100% sure yet, but we're gonna try to make a little game together, I guess. Also, why is this like up here? It should be here. Perfect. Also, we're deleting this one. It was just for a test. So don't mind me jumping around crazily from left and right. Yes, we sorry. My PC confused me when I looked at the camera and it was not there because the camera thing from Nvidia to remove the background from my webcam was set to the new game capture card. And it took me a while to figure it out. But now we're here. Also, I was early yesterday, I think. So it's fine. Told you guys I will never be on time anymore, ever again. Nice! What are you cooking, my man? I love cooking myself, so that is actually something that is interesting me what you are cooking. We had spaghetti and bolognese sauce today. I needed to make it vegan because my girlfriend tries to lose weight right now. But it was tasting okay for vegan food. I will have to say that. Nice. No, I did not finish the Digimon demo actually. I started it. I skipped all the story cutscenes because I knew I wouldn't have a lot of time. But it's insane. Dude, that sounds awesome. Chicken steaks, wedges, and baked beans. That actually sounds so good. I'm not sure what we eat tomorrow, to be honest. Because that is always kind of like a mystery bag of whatever I think of we could cook and whatever the others are fine with eating. But yeah, guys, let's talk game design. Because Lydia said I should do a stream where we try to do a game together, every one of us. You guys pitch in the ideas. I'm sitting here trying to look not as if I'm a total idiot at what I do actually for a living. Which will go horribly wrong, I would say, but we're gonna see. Also, if you can see, my shirt is really fucked up like here. Was a v-neck, but kind of got destroyed in the washer. So guys, in the beginning of like thinking about what game we want to create, there is usually like a step of brainstorming and thinking about stuff. I actually brought you guys something funny. This is the game design document for a game called Race and Chase from the 1995. That is what a lot of people and professors actually use at universities to teach people how to do game design documents. This is like just as a background info for you guys. This later was renamed. Race and Chase was not how it was named when it released. Damn, only 1 hour and then you didn't even skip? I think I played like half an hour. But I also battled everything because I wanted to evolve Digimon. Maybe that was my mistake. Because I actually left and entered and reloaded quite a bunch of times to have them respawn. Which one did you pick as a starter though? Because I picked Devimon. Because to be fair, I know it's gonna be evolving into Lady Devimon, which in the last 3 games was like OP as fuck with her AoE attack. But yeah, guys, to come back to this, Race and Chase, this game design document is so good for getting to know how to do one. Simply put, because it was renamed later on to a little known game called Grand Theft Auto. So if you want to see what everyone ever thought they would do with Grand Theft Auto, that is what their initial vision was. We're gonna go over it real quick, just so you guys have an understanding of it. But yeah, this one later got leaked at some point. It's not really complete, like you see here. Target system, development system, that whole point is gone. It's also not that important for us anymore, because when you go and talk to like what is the target system, it's usually like, oh yeah, we put it on Unity or Unreal and we can just export it to literally everything without that much of a hassle. Back in the day, it was different. So let's go through this real quick before we start designing our own and talk about it. So here you have like the first page, doesn't matter. This is the revision list. So what you would do in normal... You pick Patamon? Damn. Yeah, I have to say I don't like Patamon because of the first Digimon Adventure series. He was like such a weak ass bitch the whole time. And then once he finally managed to evolve to champion level, he literally uninstalled himself afterwards, which was, kinda, I don't know. Give me a second, guys. I'm gonna grab something to drink before I talk my mouth dry. Okay, guys, I'm back. So yeah, what you see now is a revision list, which is basically used like version control. Sure, he was broken, but he also wasn't a War Greymon. But yeah, to be fair, he was pretty cool at the end. I'll have to give it to him. But that doesn't change that the underlying feeling I have for Patamon is that he is like a crying little guy. I don't know. But yeah, like I said, this is literally like version control we have nowadays in computer sciences, where you can see when it was revised or reworked to fit the current status of how they wanted to develop it. So then you usually have like a table of content, and then you go into like, what is this about anyways? It's like a short summary of like, yeah, Black War Greymon, insane. Really like that one. Was like the badass evil version of the War Greymon, and then later on became good. I really enjoyed that storyline of him. But yeah, and then you define the scope, which is like the scope for this document, not for the game. Then like just general conventions, how you write it, general references, like you would find in literally every piece of written document that has a scientific background, because this is nothing else than a scientific background. So then we come to the, I would say, more interesting part, where you describe in more or less detail what this all encompasses. which is gonna be like the concept. So like in the example of Race and Chase, it was like it's to produce fun, addictive, and fast multiplayer car racing. There you see how far they strayed from that. Yes, it's educational errors. Before we go into video game creation, we're going to talk about where it all began and what actual professors at the university use to teach people how game design step by step works. So I thought it would be a good opener to talk about the most prolific, probably, design document that was ever released, which is from a little unknown game called Race and Chase, which got later renamed in like 95 and would become a small unknown indie game called Grand Theft Auto. That's why it's so famous. And also because it's like one of the oldest ones you could find, and it literally didn't change since then. There is like different things that changed, small minor details, but in general, this is like a document you would use still for like multi-trillion dollar stuff. It's from Rockstar Games, which I think is not even mentioned here because they weren't called Rockstar Games back then. I think they renamed later on. Don't fact check me on this, but I think they weren't called Rockstar Games at this point. So yeah, so literally what we would do then, or what you would do then, is going into the specifics, like the concept, what is it? It's like a racing game in the beginning. Then you would talk about what game setting do we have, so everyone is on the same page. Then you have the game structure. In this case, we have like 3 cities. There will be multiple missions, stuff like this. Because I don't know, maybe you guys are too young, could be. Not everyone's as old as me. You couldn't go out of the car in the first GTA. It was a driving game. And GTA 2 was, I think, or 3 was the first one where you could go out of a car and start blasting people. So, and there is something interesting that you will see in a lot of game design documents. It's when it comes to, for example, 0.5.4. The PC game will be playable by multiple people across a network or by one player at the standalone machine. Console versions will allow 2 people at one machine. They actually, back in 1995, were thinking about making it a multiplayer game over a network. Which, to be fair, back then you have to think about, like, for example, in Germany, we didn't have internet back then, at this time. You had LAN, but that was also a hassle to set up because the PCs weren't really light back then. So yeah, but you literally would fill in all the stuff to just make a cohesive first idea of what you want to do with the game. And then you would also specify stuff like the graphics. What will it be like? How is the landscape gonna look like? This is actually very detailed already. Most of the design documents I have looked at are not that detailed anymore. That is also to do though with the limitations they had back in the day. There is one point, let me show it to you, where they actually calculate how many bytes per face and how many faces per style. So how many total bytes one graphic would use for the face or for the compressed world and stuff were allowed, because otherwise it could have been that the whole game runs horribly, because like back in the day you needed to be careful about the amount of space on the as well on the RAM, as well as like the CPU, and as well as like the hard drive you put, because otherwise the game would run poorly, no one would like it, and we would never get GTA 6 in probably like 25 years. Yeah, I'm looking forward to the release of Digimon Storytime Stranger 2. It's gonna be good. So now there you have the target systems. Like I said, this is pretty much not as detailed anymore today. Now you would just go like, oh yeah, we use as a tech stack Unity or Unreal Engine with like Visual Studio Code to produce the code and the software, and we can put it out thanks to that to like Switch, PS4, PS5. Xbox 360, all that jazz. We're gonna get to coding soon, Lydia. But first, I want to have my lecture. You guys need to learn something here. Okay, so where was I? Yeah. So you also see there, it's like when they talk about, we put it on DOS. They talk about, they're like, oh yeah, we have 32-bit flat memory models, which will require 4 megabyte of RAM. This limit may have to be raised to 8 megabyte of RAM. Not gonna lie, 8 megabyte of RAM back in the day was a shit ton. That was like what probably those guys rocking like 56 gigs of RAM are nowadays doing. So this is all what needed to be included in that. So just so that the coders and the programmers and the graphic designers would know what limitation they could put in. Yeah, I'm also not a vibe coder, because I think I'm not good enough of a programmer to vibe code without thinking too hard. Because wouldn't vibe coding be like, oh yeah, let me just beep boop, and there is code coming out? I have cursor, actually. We're gonna vibe code with cursor. So, and yeah, at the end, you have the gameplay setting, which is nowadays usually a lot bigger. But it displays like, how should the world be? What is the landscapes? How should the different things look and play differently? How are buildings, for example? Then you have like the ground types, which should all do different stuff in the game, obviously. Then they go into specific, like, what are the cars? What are the intelligence? Like, if you think about it as like a horror game, you would think about it like, okay, we have the world, we have like the landscape, that would be the same. Maybe you also have ground type if you do like some weird shit about like, oh, when he steps on glass and it cracks, the monster can hear him. Then you would put that also all in like stuff like this. Then you have object types. Normally you wouldn't do them as detailed as this anymore. But you would do like, okay, we have weapons, what is the intelligence, like the AI that we put in, all that kind of stuff. Then you also have like the enemies, which is like the police in this case. That's why it's only listed as police. They can also shoot at you. Duh. And then you would go into like, how should the game control? Like, do you use a controller? Do you use mouse and keyboard? Stuff like this. And then it's also important to go like, okay, how should it look? The intro, in that case, they already stated, oh yeah, let's do a pre-drawn rendered animated introduction to the game, which, if you didn't know it, it's like a car driving around. Also, the menus, like, you see that they're referencing stuff here. They didn't have a clear idea when they put that in. So it's always good to have like a reference where other developers or team members can just go and look at it. For example, they could just go and see like, oh yeah, what is Doom like? It had like start, continue, options, quit. I have actually no idea when they started with agile development. But if you look at this and that the design document was revised like 6 times, I would say that is like one of the first starts where you would see like some kind of agile game development. Probably developed over the years more and more. But yeah, that is literally also one of the aspects of like how agile development driven works. Revising and reworking and testing, doing stuff. Though to be fair, it was revised very early on. Yeah, the inflation of file size is insane. If you think back, like this is literally 30 years ago. 30 years ago, we were talking about stuff like, where was it? 4 megabytes of RAM, and that it may needs to be raised to 8. Can anyone of you guys even think about a program that just takes like 4 megabytes now? Because I wouldn't know. I think there isn't even one like background process on Windows that takes less than 4. True, 12 to 16 was for the N64. That was really great. For 16 only if you were rich enough to get the expensive as fuck games that had the expansion pack. This is actually a funny one with the mirrors, because the mirrors are not only because like the render pipelines of the from the whole development platforms did also get so much better that they can have mirrors be done with far less resources than they needed to do. Because thanks to ray tracing, it is actually easier than it was back in the day, where you needed to do like tricks to actually have a reflection in the mirror. But also, like, all the machines have gotten beefier. Like, you wouldn't be able to compare 1060 and stuff like that. Yeah, they duplicated literally everything that were in the mirrors. I don't know if you guys saw this, but there is a YouTube short or TikTok video out there about how The Walking Dead from Telltale Games actually animated the backlight mirror in the car, because like the whole gameplay is like you're sitting in the back of a police car getting escorted from the police guy, and there's literally a box behind the rear view mirror that goes like this, which just shows everything that is behind you as a second camera angle, just to have like the effect of a working mirror in this game, which was insane. And that game is not even that old. But okay, that is enough of me rambling about. Let's do like a minimalistic version for ourselves for a game design document. So we have a point of reference where we can come back to and can also work on it step by step and a bit more. Ignore that it's in German. I'm German, by the way. But I can type in English. So we don't have a name yet for our game, so since this is like mostly horror games we do here, let's do like it's a horror game. So usually you will put in this like introduction thing. Don't mind that it's not that as clean as I would show you, as I showed you before from GTA, but deal with it. Introduction, you would go like this is a document displaying what we want to do with our game. And if we look at the table of contents we have here, there's like references. We obviously don't have any, because why would I come prepared? And then we have target systems. We can put that in. Target system. Anything we can hit with Unity. Because thanks to Unity, game design, game programming has gotten a lot easier and a lot less of a hassle today than it was before. Just because you can just click a button, do some minor adjustments, and you can just put it out on any other platform, which is great. We'll get to there when we get there. You guys will learn a lot, I will learn a lot while we do this project. So our development system is gonna be a Windows 11 PC and Unity, and in that case we're using Cursor. Yeah, let's build our own graphics and physics engine. That is a good idea. It's not gonna be a nightmare anyways. And while we're at it, why don't we just write our own specialized OS? Yeah. Two dumb people, one great idea. So development system, we will put it like this. So you guys would know if we would work in a team, if someone wants to collaborate, everyone would know, okay, the development system is gonna be a Windows PC. That also, to be fair, not that important anymore in modern times. And then we could just jump into, like, what do we want the gameplay to be? Let's reference this again. We know specifications is here as well. Actually, let's do them first. So what would be our specifications? It's like literally what would the game be? It could be something like we are in our home and some dudes want to get in to kill us, and we have to do specific things per enemy to make them not kill us. The goal is to survive until the end of the night. The cycle will be from 10 p.m. to 6 a.m. because that is like the gaming times, I guess. Yeah, like let's do a game like scrutinized welcome to the game, where we have like killers entering our house, we need to find them, do specific tasks like that, and try to survive. Actually, let's also put in a gun that the player can get, just so we have the thing that I always wanted in those games, where you can just shoot the killers. Optional. Let the player find a gun and shoot them. No, I'm not gonna go and make a multiplayer game, cause I once, like, my girlfriend once had a project for her university where she looked into how to make a multiplayer session. And because I was interested in that, I looked it up as well. And oh my god, is that a hassle to make like session IDs, sessions, and everything. Like, I will never make a multiplayer game. Not in a million years. Because that is just a hassle. Okay, so then we have like the game world, which would be like, it's the house. Yeah, Google, I know it's there is a like a string missing. It's the house of the protagonist, because she was on the dark web, killers want to kill her. Make it a she? Okay, so guys, we're already making this game pretty specific. It's a she. No one will ever know because we will never show the character. I will show you guys a cool trick how to make a first person character, and that is literally not having a character, just a camera. So we have that done. We have this done. We specified it's playing at night and stuff like this. Yeah, Lydia will do the voice acting. So it's gonna be only a girl. Since she wanted a girl, she has to do the voice acting now for free. That is how you bully people into working. Okay, so let's talk about gameplay. So the player. It's like first person. You can move freely in the house, but cannot leave it. Left mouse button or the E button is gonna be for interactions. And it's gonna be stuff like opening doors, opening and closing doors. It could also be stuff like picking up items. It could be for shooting a gun. All that kind of jazz. And now comes the fun part, guys. Let's talk about enemies. It could be something like enemy 1 is going to be a handsome guy in a lab coat. You get that kind of jazz. Well, since I am not very good at doing 3D modeling or any kind of modeling or any kind of art, what we're gonna do is she is definitely gonna stay in her house because I have a nice art piece of that, which I bought quite a while ago from the Unity Asset Store, which makes it a lot easier. But yeah, guys, what do you think we should do? Do we want to go like the route, since this is literally just a learning progress? It's not gonna be a game that I will release at some point or anything. Like, I will give it out to you guys in the Discord to try and play it and test it, but obviously we're not gonna be releasing it. So do we want to go the route like Dead Signal, where she is like supervising? I actually like that idea. Let's switch the game world thing around. So we now have the idea that the house is haunted and the protagonist is a ghost hunter. Actually, I think that is a good idea. Who tries to find ghosts. Which try to kill her. And there are specific things, yeah, like paranormal activity. She needs to look through cameras. She looks through cams on her laptop to spot anomalies and needs to survive the attacks from ghosts and other beings like demons or stuff like that. Actually, yeah. Let's build the Luigi's Mansion thing as well. She can find a ghost vacuum to clean up the ghosts. I mean, there can be normal killers, there can be other stuff, like, this is the nice thing about game development, right? We can let our imagination run pretty much as wild as we want, especially when we say this is not gonna be a commercial product. This can be like the most retarded fun we guys can have. So let's think about like what kind of enemies could there be, and like what could we do? Like, for example, one enemy could be a poltergeist. It's Photon, yes. I remember it as well. Thank you, Naganek. Welcome to the Happy Text Thursday, where I will talk and talk and talk about game design, other stuff probably as well at some point. And you guys need to listen to it. Let's do like one enemy as a poltergeist, and he will throw stuff around. And in order to survive, you need to clean it up. That is like one type of enemy I could think for. The vampire idea is also not bad. It's a vampire. He wakes up from his coffin. In order to survive, the player needs to find the stake and ram it through his heart. I really like that one, that idea. So guys, any more interesting ideas you might have for like enemy designs? Let's go like for 3 to 5 enemies at least. I mean, we can build secrets in, but we should focus first on making the core gameplay so that it's working, and flesh out a lot of stuff afterwards. Because if we're gonna start with feature creep in the beginning already, we're never gonna finish the game. Because that is something I learned the hard way, is like, when you don't do something like this design document where you put yourself in a specific track of what you need to do, there is gonna become a lot of feature creep where you think like, oh yeah, it would be so cool if she would have a shotgun that shoots salt, and if you bang it into a ghost enemy, it will make them disappear for like 5 minutes. That is a cool idea, but if we're gonna spin that further, then okay, the next one is a garlic cannon made out of a potato cannon to shoot at the vampire. And then there could be like, I don't know, a normal gun as well that we can shoot at like normal people to make them ghosts, and then shoot them with the salt shotgun and stuff like that. We can write down that we want extras. Later on, we want to develop some secrets and Easter eggs. But let's keep it at that right now. So guys, come on. We need one more general idea for an enemy, which would be awesome. There's the question though. Yeah, I wanted to say, like, we could make it also optional idea. Random people coming to your door asking for entry. Some will help you, some are vampires and kill you when they are allowed to enter. Yeah, the good people would literally just hand you like some item or something that will help you, make it easier for yourself, and then would go like, peace out, and go again. Meanwhile, if you don't guess it's a vampire and he enters, he will fucking kill you. That would be one of the ideas. A werewolf slash rabbit? Werewolf slash rabbit. And how would that work? Because I have no idea right now in my head how that would work. Like the same way, it's a rabbit that knocks on your door. If you let it in, it could be a werewolf. Well, we can keep it like this for the moment. There could also be just like a normal murderer who enters the house to kill you. And you either need to spot him on the cams or shine flashlights at him. The brides that die, you mean like the woman in white? Yeah, that's a woman in white. Yeah, we could put that one in. Woman in white. Would probably be like the player hears sobbing sounds. Needs to bring a handkerchief to the ghost to not die. Damn. Now we're building on top of on top of on top. So you think we should still do the thing where she looks through her cams and spots anomalies? Meanwhile trying to survive the ghosts and the murderers and stuff like that? And also tries to help them? Damn. This is gonna be a very big scope game. Far bigger than what I thought we would do, but let's put it in. We can always scratch things off and not do them in the end. But for now, it's probably a good idea. She can help the enemies achieve some goal to get a better ending. Okay, yeah. A random animal in the house which could transform into a werewolf. Silver will fend them off. Okay. So the question now stands though, since Lydia came up with the idea we can help them. How would we help them? Like, for example, how would you help a murderer that goes into your house and trying to kill you? Would he just go in and we go like, oh wait, next door, the guy, he has like a bad leg, he cannot run that far? He is a far easier target, man. Like, look at how much I shine my flashlight at you. If we want to kill someone, this guy over there, like he had 15 burgers from McDonald's today. Just get him. He will not run away. True, true. Let's put that in. So yeah, guys, any ideas of how you would appease those guys those enemies that we just thought of? Without sending the murderer, for example, literally to the guy next door that is a fat ass. or old or too young to walk or whatever. That is the question, because, like, for example, a vampire obviously wants to drink blood, right? Also, a murderer also wants to kill you. Oh, we would need to scrap those ideas and make it only ghosts, which we can actually help overcome the grief. So we're gonna scrap all that and make it only about ghosts. That is a good idea. So those guys go away. And we need more ghosts then. King Boo returns. I mean, we can do like a shy ghost. Hiding from the player because he is shy there. Finding him makes him not kill the player. So there we have 3 ghosts. I think that's enough for enemies for a second, since we need to think what each of their goal would be, or what we need to do in order to appease them. Oh, okay, I will put in TV screen ghost as well. You got me on that one. That is really cool. So how that could work is, for example, static coming from a TV/screen. Turn it off to not get killed. So guys, what are we thinking could be the goal for the poltergeist on how we can make him not wanting to murder us anymore? Like, one thing could be cleaning up the whole house. Or like finding stuff that shouldn't be where it is, like a teddy bear, picking it up, bringing it to its room, making sure that it's there. Then the ghost will be happy because you, I don't know, cleaned up the mess it made. Okay, let's put in a kid ghost as well. But guys, this is the last kind of enemy we put in. Vengeful kid ghost. So what would he do? Okay, searches for a toy. Bring the toy to his room to calm him down. And the goal would be find his favorite toy and return it to free him. You guys see though, right, that you're working on feature creep quite hard right now. There is written notes to explain. No, it's fine. It's actually a good thing. So we can flesh everything out. This is actually like a good point to make, like, as much assumptions as we can. And then when we're done, go over the whole thing again and rethink about it, make a new iteration of it, and make the game that we are gonna do a lot better by that. Because there's nothing worse than thinking about an idea the first time, thinking, oh yeah, it's the greatest thing ever, or not thinking about it, then coming back to it when it's actually time to work on it and realizing, oh, that's not fitting. So having more ideas and having feature creep, quote unquote, now is actually pretty good. to explain certain story elements, i.e. How to find the favorite toy of the kid ghost, how some ghost died, what his grief is about, why he is still here, how to free the ghosts. That is actually a good idea. Kind of making a quote-unquote puzzle game out of it, where we need to find clues on how to free those ghosts. I like that idea a lot more than the first one already. So the poltergeist wants us to learn the truth about his death and free his soul by uncovering the secret. So the woman in white is a sad ghost that is only still here because a loved one or something did something horrible to them, which caused them to usually finish them off themselves. Well, we could make the TV ghost pure evil. We could make the TV ghost more evil, and literally the goal is to find a baseball bat or something and smash literally every single TV so she cannot enter anymore. That could be one. There could be a multitude of things that you could do and we could do. So she's gonna start roaming around from one screen to another once the TVs were on for too long. That is actually a good idea. We put that up here. So she cannot spawn. This invokes her cooldown for spawning. Okay. That is a lot of technicalities. So let's also put it in here so we don't forget. Leaving one screen makes her go to another and disappear again. If she sees the player, she will chase him. Break line of sight to make her stop chasing. Yeah, exactly. Like if we break line of sight long enough, she will stop, not killing us. And that will be how to deal with her. And once she's done not seeing you anymore, she returns to her original line of travel where she goes from one screen to another to get in to not be in our living world anymore. But that also doesn't bring us closer to the idea of how to deal with her and how to finish her off. Because if we want to have everything being like, okay, somehow we free them, we need to have a winning state basically for her. Also, we're still going for the 6 a.m. thing. Because what happens if she's the only ghost and we freed all the other ones? Wouldn't that make it too easy? Okay. That is a possibility. So, which also means that ghosts can respawn, and so the nodes need to respawn and have different text and advisors every time. That is also a good point. If two... That would be gameplay though. If too many enemies have spawned, the game will end in a game over screen. I mean, with the constraint that if too many ghosts are spawning, that you lose the game as well as too many anomalies being there. That also makes sense, because imagine if you get like Giga RNG and it's gonna be a bunch of TV screen ghosts that just roam around away from you. And you just sit upstairs or downstairs or wherever on your laptop, clicking away on all the anomalies you see. And then you get lucky, basically. So I guess having a maximum number of enemies that can spawn before you die. Oh, now we're talking about a store as well. A upgrade store for new equipment, making it easier to fend off ghosts. Yeah, what I think how I would imagine the poltergeist would be, you can see on the cams when he throws around stuff. And then you go into that room, clean it up, because I would make them all just gonna be like rooms where we can actually go. So you can also see the anomalies happening in real life, spawning in real time, and then kicking them out only on the PC where you need to go and tell them. I think that would be like a nice idea for how the anomalies could be incorporated. Damn, you guys have a lot of ideas. Yeah, definitely we need sound cues. Let's put in a sound thing here. TV static for the screen ghost, also sobbing for the woman in white. I would say probably like if the kid ghost is vengeful and mischievous, I think like children's laughter for kid ghost is probably a good idea. I mean, you have different kind of things that you can hear, like items being thrown for poltergeist. The question is what kind of effect you would do for a shy ghost, or should that be like really, really silent because he's shy? Let me also put that in, Siswi. Multiple tiers of items to deal with harder ghosts. Oh yeah, that is a good idea. Shy ghost. Only visible on cams. That is a really good one. So I would say let's not do ornaments and stuff like this then, but since he's only visible on cams, let's do it like changing lenses will make him spottable. So that there is, for example, like 3 lenses. One is like ultraviolet, one is heat-seeking, one is, I don't know, night vision, and you need one specific one to see him and need to flick through them to actually see him. Which is a good idea. So you mean like jumping on or looking at him for long enough? An instance? I mean, yeah, we could tie that together. Burning an incense clears the ghost away. We could make it so that there is like a book explaining the ghosts, i.e. which lens to see a shy ghost means which incense to burn to deal with him. So that we have a book like the one in Phasmophobia or Demonologist where you literally can flick through pages. And then you can literally get an explanation of how the game is supposed to be played, which would be an in-universe tutorial for the game, which would be nice. But also, yeah, going there, seeing like the Shy Guy ghost, that would be a good idea. Also, guys, if we play something right now, since we have no audio right now in the stream, my headphones turned off. I just look at chat, that's why I saw it. Yeah, sure. The book also functions as a notebook for the player to write important stuff like favorite toys or place of death or something, whatever we come up with later on. That is a really good idea. So guys, I think the only one we're missing is how we make the woman in white happy. Which could be that there is a family picture of her and her family and we need to bring it to her. That could be one. Remember to save it often? We're allowing saving? Yeah, we should think about the save system. Oh, the doc. It actually goes like an autosaves every time I write a word. Like, see? There are hints for what picture is her and her family. Finding the right one will free her. Finding the wrong one will kill the player. Triggers a screeching jump scare death. Oh yeah, I think like when we do it like this, so my idea right now is, let me actually jump into Unity for a second to show it to you, because we have like a demo scene. Is this one the night one? Which one is the night? There we go. So I will explain to you guys Unity in a second. Just deal with me right now for no explanation. Also give my PC a second to finish up his stroke he's getting. It's a lot of stuff that he loads right now. There we go. So what we nicely have already is literally a fully lit map, which is in the dark. You can see what it would look like if the game fucking renders. There it is. We will do some adjustments for it, but how I thought about how we would do it is like, for example, we have a TV screen right here, right? So we would place different cameras all around here, maybe like this, that you can observe, and you would see a static effect going onto this screen. So what you would do is, if, for example, we say the room of operations is in this room because there is a laptop already, you would see that you would go like, oh no, what should I do? Let's hurry down the stairs, click the TV, and turn it off. Damn. I like that idea. So this house, by the way, will also literally be what we will use, like this map as well, because it's a time-tested map. It wasn't so many games, and it also kind of looks nice to make everything. So it's a nice small scoped house. Also has a fucking nursery. So guys, just a bonus question: who thinks of you guys knows where all of this asset pack is actually used as well? In what game? Yeah, it's actually yes, it's it is the thing that the Phasmo devs used for all the city houses. This is like probably one of the most used assets packs. Also, thank you, Agratorias. Really glad you enjoy this. It's a different kind of format than I usually do, so I'm kind of excited about that. um, but yeah, we will touch on some stuff, make it look a bit more creepy and decrepit, hopefully. But this is gonna be like the main map that we have. Um, but yeah, now that I explained to you guys what my idea is for the TV ghost, which you guys came up with, luckily, um, I think we're actually pretty far into the first draft of our design document. Wouldn't you guys say? Also, we need to put in VHS mechanic to make her not spawn for a period of time. Well, if you look at the map, it very depends on how we are gonna use it. Like, for example, what we can do is, you see this table, right? So this table right now has a mesh collider. A mesh collider is literally just a invisible block or wall that, how it is put like this, if you would go here and the ghost stands here, he would see you. If you would go over this way and crouch, the ghost would not be able to see you because this is treated as a concrete wall. Same goes if the ghost is standing here and you move here. He would not be able to see you because his LOS would be breaking at the wall, which also has a collider. So as long as the ghost is just a little bit faster on running than we are, there is a lot of hiding spots, because you could also just go and open this door, stand in that bathroom, close the door, and wait. You could also just run up the stairs and hope the ghost wasn't right behind you. Yeah, we could. Let's put that also in. Fast 2.0. There's a hub before the round to buy upgrades for the next one, which also means there is a currency to get after each round, which can be spent in the store for items. Okay, guys, while you guys think about an MVP mechanic, because I don't know, I'm gonna go pee real quick because I drank quite a lot because I'm talking so much this time. Okay guys, I'm back. So now we think about also having a hub where we can start the rounds, which also means from a gameplay perspective, we have a hub. The hub has a store. In the store we can buy upgrades with currency earned in previous rounds. It also means in the hub we can start the round, which could also mean later down the line that it's where we can select maps. Some one-time use items and some permanent items can be bought. That's how you say it. Some items are limited in quantity. The more limited they are, the stronger they are, which is a really good idea. But that will require a lot of balancing. Okay, so guys, what we didn't talk about till now is actually items, now that we're talking about putting them into the game. So obviously we have various household items that the poltergeist can throw. And also those can be picked up by the player and put back into their original position. Which also means there needs to be an indicator or like a snap point where the items go. Okay, so we have the VHS tapes for the Screen Ghost, which will be like different brands, colors for different amounts of time that they disable the ghost. That is a good one. So we also definitely have i.e. 30 min, 60 min, and 90 min of in-game time. Then we have the notes. Those can be picked up and read by the player to gain information. Yep, that's it for now. Don't look at my emails, guys. What else could we and do we need to put in? It's also family photos for the woman in white. Oh yeah, that can also be a checklist for objectives to clear strong ghosts. So we have family photos. Those need to be able, can be picked up, can be shown to the woman in white when she spawns. So if we do it like that, we also need a new tab and a new like headline for objectives, which we need to fill. And I guess now you guys can actually really see and appreciate why it's so important to do like one of those game design documents, because like we're brainstorming the idea like heavily now. And we see like so many different things that if we make them out right now to be really clear, we can easily derive the next thing we need to do before we actually start into developing to make it. Okay, we put that into the items. Actually, we're gonna make another one as well, which we call upgrades. And for the player, we also put in has on default 3 inventory slots, which also means we need to do an inventory system. So one of the upgrades would be a backpack, which simply put increases the inventory size by 1 per upgrade. So it could be in the beginning, it's like a fanny bag going to like a handbag, going to like a backpack, going to like a camping supply backpack, all that kind of jazz. I like the idea though. That is really cool. We need an inventory system, so the first thing I would think about is like quick buttons, mouse wheel, rotate through the inventory, and the selected item is going to be held by the player. Pretty simple, should do the trick, shouldn't be too hard to implement. Okay, so we also need different toys. And if you think it's redundant that we put like various household items, family photos, and toys, even though they nearly have the same things on a mechanical level, it's also to remember us that we need to look for models, objects, game objects that we can use for that as well. So we have a specific checklist that we can work off and do like this. So these also can be picked up and placed in the nursery by the player. And these are used to help free the child ghost. We put that into brackets right now. And just make a general note, look for a Game Boy model, because that would be a nice funny touch. Okay. So do we miss anything? Oh yeah, we actually miss a lot. We miss incense. Incense can be picked up next to the PC. 3 different kind of incenses, depending which lens makes the ghost visible. Determines the incense needed. We're just gonna make a lot of cross references here as well to make us not forget what it's for. Simple as that. An animal plush. So we have, I think, all the basic items that we would need in the base game for the 5 types of ghosts we have, right? We have like the household items that we need to place for the poltergeist. We have the VHS tapes to make the screen ghost disappear. We have notes to figure out like secrets and stuff like that. We have the family photos for the woman in white. We have the toys for the child ghost, and we have the incenses for the shy ghost. What we also need to think about now that we're talking about items, objectives, stuff like that, it's the camera. So we have different cameras in different rooms. And we can, the player can switch them. Player can switch cams via A and B button. The player can switch lenses via W and S button. Player can leave cams by pressing the X button. Yeah, the toys will be scattered around the house, literally, and you will need to find a note going on like, "Oh, my poor Charlie died. His favorite toy was Coco Melon." Now you guys also coming around with difficulties. Okay, so we have another point to fill, which we will. Okay, so since we set an upgrade system for the cameras as well, I mean, yeah, it could be that camera. We could make it so that different upgrade levels make the screen less pixelated. What we could do there is literally just reduce the render size of the picture that we see, making it a little bit less crisp. Once we upgrade the cameras, it goes up to all the way to max resolution. That is also a good idea. Okay, so we have difficulties that we want to talk about as well. So, doing it like most game developers, casual, normal, nightmare. We steal the ideas of someone else and making it our own. I mean, yeah, we need to see what we actually implement in the MVP, but that is the step afterwards when we talk about like how are we gonna take it off and make a small project out of it, which could become an MVP. That is actually a cool idea, I think, for the TV ghost. Disables the cam it is visible on at the time. Well, we can just put in like a static effect where the ghost disables the camera, and if you stay too long on that cam, there is a chance that the ghost comes out of the PC screen. I think that's a cool idea. I really like that one. So what would be, though, if we're already talking about difficulties, what would be casual difficulty? Would that incorporate all 5 ghosts? Would that incorporate not needed for the first stage of development, and also nightmare not needed for the first stage of development? Yeah, I think the TV ghost is probably also one of the ghosts that we are working the first on, because that is, if you see how much we wrote to every ghost, like Poltergeist, Woman in White, Shy Ghost, and then look how detailed we already got on the Screen Ghost, that is definitely gonna be like the first ghost we probably work on. One, because it's the most complex one probably to set up. But secondly, mechanically speaking, it is probably one of the easier ghosts where we can take most of the mechanics that he has and twist them around a little bit to make the other ghosts work as well. For example, the Shy Ghost, we already have the all detect what ghost is on the camera thing in place from this one. So that one is written literally in minutes after this one is. At least the first draft. That would be an upgrade. A PC upgrade. Software to fix the PC. By the way, since we're talking about that the PC is also there, what we didn't talk about is the gameplay of the PC. That is true. That is as well true. And also, if you look at it like this, the Vengeful Kid Ghost has like Return the Toy, which leverages a lot of place back the items the poltergeist throws into specific places. So literally what we have here is like, with this ghost, we basically have the groundwork for all the other ghosts, because we have the VHS tapes that you can pick up and place somewhere, which is literally, mechanically speaking, even though it looks differently, the same thing. We have for her that she starts roaming around, which will be needed for literally every ghost. We have a camera detection thing, which will be used for him. The only thing that we actually would need to do there is gonna be the note system for the other ghosts. Okay, so guys, which of the ghosts are we scrapping for casual mode? I would say we scrap the poltergeist. If you guys are fine with that. Because I think he is more like a mix of the Shy Ghost and the Kid Ghost more than any other ghost has an overlap with another one. Also, he could potentially be the hardest ghost in the game, because Because he requires you for him not killing you to place back like small items like plates and cups that he throws around in the specific place they were in before. So that one could be the hardest one. He could be the breather of the ghosts. Okay, but with that, I think we have a interesting collection of stuff, but also we are missing stuff still. So we have the PC, which means we also have reporting. How do we want to go about reporting, guys? Could be like we're clicking on stuff, it's a circle appearing around the mouse, and if we hold it long enough, it's working and it just gets reported. Or do we need to tell whoever is compiling those things well, that is the question though, isn't it? If we do anomalies only with the poltergeist, or do we do like general anomalies as well? Because that would mechanically change the poltergeist a lot. If he only does anomalies and we need to report them on the cams, it makes him a lot different than if we can see on the cams when he throws something. Need to go there, pick it up, place it back then. And that we have like general anomalies spawning, which are just tied to there being ghosts in the house. Like a bunch of skulls spawning, or like a doll hanging from the ceiling or whatever. So, do you guys think we should actually only tie anomalies to the poltergeist? Because if so... Okay, so reporting is not gonna be needed for the MVP, which also changes the poltergeist. Poltergeist will make anomalies appear on cams. Player needs to fix them to not get killed. I mean, yeah, that makes it more important and makes the ceiling for the first difficulty a lot easier. Also reduces a lot of development time, I would say. Okay, so the PC right now in the beginning is just for fixing and looking through cams to figure out the other two ghosts. Which is pretty fine for me. So with that, I would say our game design document quick starter guide thing. Yep, we could do that. We could definitely make them reportable by the PC, so the mystery man fixes them like in every other anomaly game. We could also force the player to do that, but since that will not be needed for... Actually, that's a good idea. So on normal difficulty, you just click that there is an anomaly and click on the anomaly. And on Nightmare, you need to go there and fix it yourself. I like that idea. let's mark this in normal. I mean, yeah, it changes the pace of the game. But think about the breather in that signal. That motherfucker changes the pace of the game. And for now, it's also just an idea, so we can put it in. And it can be done via PC. Reports anomalies need to be fixed by the player. No more PC reports. That is a good idea. Okay, so guys, let's go through this one time. Say what we think in the end. We can already take this one out. And if we're all happy, let's continue with the next step. So, what we say, it's a horror game. It's this is displaying. We can make any target system that Unity can target. We use Windows PC and Unity and Cursor for development. Also, it's not anymore some dudes that want to kill us. It's some ghosts. Want to kill us, and we have to do specific things per enemy to make them not kill us. Okay, let's put in cameras. Different jump scares need to be made, i.e. Tanny jumping, head popping up. Okay, and lore-wise, they are tied to the shy ghost messing with the player. Sound cue? Well, yeah, we'll put under sound. We also do like jump scare sounds for the shy ghost on cams. So we have that in. Okay, let's go through this now and fix any errors that are still in here. So the house is haunted and the protagonist is a ghost hunter who tries to find ghosts which try to kill him. She looks through cams on her laptop to spot anomalies and needs to survive the attacks from the ghosts and other beings, while trying to help them reach the other side. I'm not sure. I think we're gonna scrap the idea of a ghost vacuum, guys, right? Because I feel like that is out of place now. So she can help the enemies achieve some goals to get a better ending. There are gonna be written notes that explain certain story elements, like how to find the favorite toy of the kid, how some of the ghosts died, and so on and so forth. Mechanically speaking, we say that ghosts can respawn, and for that we need to have a whole system in place that figures out what the favorite toy or whatever is for the ghost, so that they get spawn new nodes when they spawn and we just deal with them. We have an upgrade store for new equipment to make it easier to fend off the ghosts, and multiple tiers of items to deal with the ghosts once they get harder. We have a book that is gonna explain the ghosts. For example, which lances are needed to see the shy ghost, and which incenses to burn correlating to the lances. We want to make a hub that we can enter before we start the round to buy upgrades, which incorporates the store. And we, of course, need to make a currency that we get after each round, depending on how we fared, to get upgrades from the store in order to have them. And later on, we will develop some secrets and Easter eggs just to make people laugh. Like, for example, the one where you get put into the fucking elevator on Welcome to the Game 2 when you try to look out of a door window. So, gameplay-wise, we're having a hub in the beginning, which has a store where we can find upgrades and items which can be one-use items, which can be permanent items. There are quantity limits on the items. With the less you can take of them, the stronger they are. And we can buy permanent upgrades like backpack inventory increases and stuff like that. So the player is going to be first person, obviously. You can move around freely in the house, but you cannot leave it. Left mouse button or E are going to be used for interactions. We scrapped the idea of a gun already, so that is gone. We're going to have opening, closing doors, stuff like that, picking up items, turning on and off screens, and also using the PC. We will also need dropping items to clear the inventory. That is correct. On default, we have 3 inventory slots that can be increased further later on. So we have enemies. For one, if too many enemies have spawned, the game will end in a game over screen. The goal still in the end is to survive from 10 to 6 p.m. So we have the poltergeist, which will be the only ghost that we scrap on for now. We have the woman in white, which is indicated by a sobbing noise. We need to bring her, for example, a handkerchief to increase the timer before she kills us. And we also need to find hints via the notes, which family is hers on the pictures, to bring her the real picture. Otherwise, there will be a jump scare, she will kill us. If we find it, she will disappear. We have the shy ghost that is just roaming the house. We can see it on the cams with different lenses. And if we burn an incense near it, it's gonna disappear. We have the TV ghost, which is... The handkerchief was like, oh, just give it to her because she's crying, because that's what you give a crying person, right? In all the movies. We can also scrap that idea. Because we have the goal of getting the picture. Then we have the TV ghost, which will not disappear. We can disable it with the VHS tapes. But it will fuck around with the cams, making them have a static image once it's on there. It will start roaming from one screen to another and disappear again. And if you don't turn the TV off fast enough, he will spawn, go around. If you turn them off fast enough, it will invoke a cooldown until he can try to hunt again. That is a good one. And we have the Vengeful Kid Ghost, which searches for a toy. Bring the room to his toy to calm him down. The goal is to find his favorite toy. If not, he will just run around the house and kill you. Okay, find the clues about his favorite toy. And then find his favorite toy and return it to set him free. So we have different items. That one is scrapped for now. because it has to do with the poltergeist. So we have the VHS tapes that we can pick up, put into a VHS recorder, and depending on the tier of the VHS, it's gonna disable the TV ghost for quite a while. Notes, we can pick them up, it will display the text, we can read it, we can learn from it, can also be a checklist of activity of objectives that need to be cleared. That's all fine. We have the family photos, couple of them splattered around the house, can be picked up, given to the woman in white so she doesn't kill us. The toys, same thing, can be placed in the nursery. Needed to free the child ghost. Good options if we find models are Game Boy and Animal plushes. Then we have the incenses, which are for the shy ghost. They should be located next to the PC to make it easier to access them. And there are 3 kinds of incenses because we get like 3 lenses. So we have upgrades like the backpack, which increases our inventory size. We have the inventory, which can be used with quick buttons like 1, 2, 3, 5, 4, whatever, and the mouse wheel to rotate through, and then the player will hold the items in his hand. The cameras, they can be upgraded to be less pixelated. That is probably something we put in later. And we have different jump scares we put on the cameras just as a bit of fun, like the head popping up or Tanny jumping in scrutinized. Then we have the PC itself, which has the reporting functionality, the cam functionality. We forgot to put that in. And software where we can fix it if something goes wrong. And then we have the cameras, which can be obviously swapped by pressing AD. WS will switch the lenses, and X will exit the PC. In the beginning, we probably make it so that the PC only has the cameras to make it easier. Then we have the difficulties. We start with creating casual, where all ghosts except for the poltergeist are there. And for sounds, we need like TV static for the screen ghost, sobbing for the woman in white, children's laughter for the kid ghost, items being thrown from the poltergeist, and jump scare sounds for the shy ghost on cams. Are you guys all okay with how our nice little design document turned out? Because I think we put in a lot of work and a lot of thought into that. And we revised it already once. I think that is very good. So if you guys excuse me now again, because I need to pee again. Old man bladder. I'll be right back, and then we'll talk about the next steps of how you make software or game development actually. Okay guys, I'm back. So, let's talk about the next step. Because right now we're looking at like a more or less complete game that we want to create at some point. The next step in software development would be like a proof of concept that it's possible to be even made and that it's actually something we should focus on doing further, which is for the keen-eyed watchers. Oh, it's going great, Agrotorius. We finished the design document, which literally outlines the whole game in its full scope. And now we're... He didn't realize I was peeing for a second ago, probably. And now we're going to talk about something that is called, in software development, an MVP, which stands for minimal viable product. To figure out what we need to program and execute in order for us to have a proof of concept that it's actually worth pursuing this endeavor even further without sinking in like a million hours of our time. So let's talk about, guys, what do we need for the MVP? What do you guys think would be the things that we want in the MVP? For one, we definitely need the house map. We need a player. A million hours isn't that much. Say that to people when they actually start paying for stuff like this when you're a software developer. They will start acting very cheap very fast. True, we just need a map, a test map. We need a player, which needs to have controls. We don't need the player. Yeah, by the way, with the player, I mean literally just an object for the player. It's not gonna be a model. Like, there is not gonna be a single finished model. Everyone will be a capsule. Like, a ghost will be a green, black, blue, yellow capsule, while the player is a white capsule. It's just gonna be for mechanically testing and working out scripts and stuff like that. So we need the hiding functionality for the player, yep. We said it's the screen ghost that we want to implement first. So for him, we need the screen logic. We need the spawn logic. We need the chase logic. We need a pathing logic. We also need screens. Those need static effects, on and off states, which also means under the controls there is movement. Actually, in that case, we put hiding in there as well. Turning on screens on and off. That should be it. And we have the screens. Then we need different game states. That is a really good... True, we need spawn / despawn logic. Well, it's a bit more convoluted, I could imagine, so let's actually put it like a separate point. We definitely need game states like start, finish, and a game over, since we need to test if the ghost behavior actually works out like how we want it. Which also means we need a clock / timer, which works for the game time. We also probably want a minimal UI, which incorporates time. That's probably it. And we also want like a menu / start screen to actually make testing a little bit better. Since otherwise we cannot start the game, reset the game, do a bunch of different stuff to check if there is like unwanted behavior going on right at the start. Okay, guys, do you think... Also, we need like a couple of sound effects to see if the atmosphere is actually working out like we want it to be. And we also need the camera system. The difficulty UI, I would say we don't need necessarily in the MVP because we're only focusing at the start on getting like the casual difficulty running, which also means actually at the start for the MVP, we want to just test a small, really small bite-sized thing from the game that we're developing. So that would be overkill, but actually what we didn't talk about is the UI, which we should say there is a main menu, which allows us to start the game. Also, we should put into our hub that we cannot only start the round, but also select the difficulty. That is a very important one. Game UI is gonna be the in-game time. I mean, you guys... Oh, wait, someone asked on YouTube Live? Sorry. Did I miss something? Let me open YouTube Live for a second, guys. Because I think it's the first time we actually have a chatter there. YouTube Live for a second, guys. Or the second. Because I think it's the first time we actually have a chatter. View my channel. Do I see that I'm live? Or the live? I hope I can see the chat, my man. I hope I can see the chat, my man. Oh my god, sorry everyone that was watching on YouTube and chatting. I am a moron, I didn't see that. Sorry everyone watching on YouTube and chatting. So let me just answer all your questions, Codebook, in the order you asked them. For one, I'm from Germany. Secondly, I am currently trying to work out what we're doing. We're trying to make a game, a horror game, about us being in a haunted house, trying to figure out how to clean up the ghosts. You guys can hear me double? I think I muted the stream though. Let me check real quick if there is like something going on. Oh yeah, because Twitch is now active. Now you shouldn't hear me double anymore. So like I was saying, we're currently making a game. A horror game where it's about like solving problems of ghosts, trying to survive till 6 a.m. to not die because you're a ghost hunter. And the full form for the MVP is probably going to be like a small test map first, where the player is completely functional. The first ghost, the screen ghost, is functional. And we have different effects and game states that we need to test out and work out. I think this is actually the full scope of the MVP, which is gonna be. Because that is probably also a shit ton already to set off. Especially like getting the whole ghost logic is gonna be a nightmare. Which is fitting for a horror game. But yeah. So guys, the next step is, for those who don't know, we're gonna quickly jump into Unity, and I will explain to you guys how, first of all, like what you see, what there is and everything, how we will set up our project and everything like that. It's gonna be a lot of nerd talk coming now, but it's very helpful for you guys to understand and see what's going on. So let's start with going back to the sample scene, because that is just empty, like you see here. So what you can see now is the Unity editor. That is where you get to after you choose one of your projects. You can make a new one by just clicking New Project, where you can select the version of the Unity editor you want. Since I want to learn more about Unity 6, because there's a lot of changes that I don't know about, we're gonna be using Unity 6. And also we're gonna use, because it's easier for the board packages and also for my PC, the general render pipeline, which is called URP. It's called Universal Render Pipeline, instead of the high definition pack, because let's be honest, we don't need that for a game of that scope. And then you can name it, put it in, use version control, which is literally like, imagine if you make a grave mistake and can just press the rewind button. That is what version control is. So after you initialize your project, you will get to this scene where you get nothing else but like a sun and a block. Nothing more, nothing less. And you will also not have those two folders, because I already imported. Yeah, version control saves a lot of headache. You won't have those two if you start it, because those two are from a asset pack. It's the house that we imported. Don't even know why we have like already a simple first-person controller. We ignore that. So what I like to do in the beginning is actually set up more folders and stuff to make everything more readable, more ordered, so that there's nothing happening where we don't know what's happening. So for one, we're gonna need a script folder. This, put pretty simply, is where all of our scripts will go. Like, for example, the player script, which will handle all the stuff that we need for the player. Is my camera angle bad? Am I? Do you guys not like how I look in the camera? Is that better? I mean, you guys are seeing everything in the screen. Oh, but yeah, maybe I should change the camera. Now I see the problem. Actually, I'm gonna be tiny and I'm gonna sit over here, because there's nothing important that you can see that I cannot show you guys on there. Thank you for pointing that out. That was very helpful. So yeah, this is literally the folder where we put up in all our scripts, which is where we store data for different kinds of stuff. Then we have a scenes folder that is pre-generated, which just holds all of our scenes. It's literally the maps, if you want to imagine it like this, that we can load and unload. Then we have a settings folder, which is right now and mostly for the whole time where we're gonna do stuff. That is the render pipeline, asset stuff. We will not touch that, because I'm not a pro on the render pipelines in Unity or in any game engine, and I will not want to break everything. What we also probably need is a folder that we name models, where all of our models that we grab from somewhere are gonna land in. So we're gonna move the HQ residents already in there to make our first folder nice and clean. Also, the not lonely folder is gonna be moved into the scripts folder, because it holds like a simple first person script. makes everything already look a lot cleaner, right, guys? So another one we want as a folder is a prefab folder. That one will hold models that have textures and behaviors and scripts already put on them. It's literally to make it easy for us to copy multiple things and build on pre-existing things. Imagine, like, for example, we make one general enemy. We put that in here. We can just drag it out and make it into whatever we want without setting it up completely from the start. Yes. So another one we also want is for controllers. That is where we put stuff like the input system, which is, like you might expect, where all the inputs are coming from, like WASD. This is a change from like a relatively newer version of Unity where you have all those different inputs, which you can then tie to different methods, which basically are actions in the game. Think of it as moving is like one method that gives your player a speed on a certain point of the XYZ axis. So for example, like you have a 3-way axis going like this. And if you want to move into that direction, you need to have a method that puts like force into that direction on the player model. We will get to that once we're into the programming stuff, but right now we need more setting up stuff. We also, of course, need a new folder where we can put all our sounds in. And we will also split that into 2 different folders on the lower level. One is called music. One is called sound effects. You might think doing those many folders is kind of redundant and a waste of time and stuff like that. But believe me, like at some point there will be a shit ton of different things in here. And having folders to find stuff easily and have them organized, it's a game changer and it will save your ass later down the line. It is one of the most important things you learn at some point. Took me quite a while at my job to learn that. That slow and steady and very clean is actually a lot easier, especially if you look at it 2 weeks later and wonder who the fuck was that idiot making it so dumb. Okay. So the next things we are gonna work on is actually create like some common scripts that we need. Because I think we're done with all the folders right now. Yes. Okay, so since we have the luxury of having one simple first-person controller already, I'm gonna show you the next thing, which is code. But first of all, I should maybe explain to you guys quickly a little bit about the Unity editor, right? So on this side here, where you can see the mouse hovering, that is the hierarchy, which is literally all the things that we have in the scene. For example, we can do a right click and do like, we want a 3D object as a plane, and it will drop it right here. And once we check the camera and where it's pointing, we should be able to see the plane. There it is, right there. So that is how you can place stuff in the world and play around with them. Like you see, we can move it up, we can move it down, left, right. You can also click it here to move it around. This is the hierarchy. It just shows you everything that is in the scene. It will look a lot more complex once we're done with stuff, but for now that's that. Up here you have like the different views you can have. One is the scene view where you can play stuff. One is the game view where you can literally see what it would look like if you look through the camera that is in your game. Then we have the asset store that just leads you to a website where you can buy or get free assets, paid assets, whatever you want. This ranges from literal code units up to art, up to sound effects, up to literally everything. Whatever you need for game design, you can probably buy there or get like helpful stuff for free. We will use that later down the line. This is the animator, which is something we will come back to later, because we don't have anything to animate yet. But this is where you would time animations like how a character would walk, how a character would have a jumping animation, and also you would put different states on there into a flowchart of what method in the script will call what method to play an animation. And then here you have the packet manager, which will give you a lot of options that might make not a lot of sense when you are a first time person trying to look at it. What it literally does is those are different kinds of functionalities that you can put in. For example, one package is the stuff you can buy on the asset store. Those are all common packages. For example, this residential house is the one that we use to show you guys like how I imagine the map to look later on. But there is also packages coming directly from Unity. And if you see like this, if it has like a check mark, it means we have it installed. If it has like this, it means we can update it because we don't have the updated version. If it is like this, it is just installed as a dependency. It's nothing we put in on purpose. It's just something in here that we have installed needs. And here you have like a whole list of everything that we don't have. Like code coverage, stuff like that. Most of that you really never use or need. But just so you know where to find it, it is here. Literally everything from VR support to multiplayer to better physics to different kinds of other stuff like visual effects, publishing for different consoles. You can find everything in here. Just so you know. Okay, and then the last part is the inspector. This will show you a detailed list of stuff that is on any given game object. For example, right now we selected in the hierarchy the main camera, which will show us the transform, which is the positioning on the map. If you see when we move it, the z-axis also moves, the y-axis also moves, the x-axis also moves the value. We can choose a render type. Base is literally like an in-game character. Overlay works a bit different. You see also options disappearing like stack and output. We will just use the base render type. Overlay is more like if you want to, like it says, overlay a second camera on the first view. You can make pretty cool effects with it, but not needed for our purposes. We can change the field of view, which if you want to have it like this, look at it, how we can change the field of view to literally every bullshit value we want. We're gonna set it back to 60 because 60 is very fine. And then it's also rendering. Also, if you notice, switching around here, the overlay and the base one literally destroyed the background, which is fine. Happens a lot of times in here. Should be fine when we move it a bit back. Never mind. He doesn't like us anymore. It's yellow for now. It will not be yellow in the end. So you have different things here. For example, if we click on a code, you can literally see the whole code here. Which brings us to the next part of developing a game in Unity, which is a code editor. And believe me, guys, we're nearly done with all my explaining stuff, like how does this program work. So we can double click this, I hope. We cannot. We can. And it should pop up our IDE, which is an integrated development, I don't know what the E stands for, environment. So just to explain to you guys as well, so you have an understanding of what we're actually doing. If someone asks you what you did on this random Thursday night, and you want to be interesting with all the knowledge you collected tonight, Unity uses as a programming language C#, which is a language developed by Microsoft because they need to be special every time. Fun little fact on the side, that's why they created TypeScript, which is a prevalent language used for web development, for websites and stuff like that, because they thought JavaScript was for pussies. What is so fun about C# though, is it's a completely open source programming language where people can put a lot of stuff in on top of it, which they did. There is a insanely big community, and if you want a framework or a library which is like pre-made code that you can use to easily and more rapidly program stuff, there is probably, for whatever you can think of, there is a library, project, a framework out there to make it very easy to develop in that language. And let me go through the code real quick to explain to everyone that maybe is not a coder or developer, so they can understand what's happening through this code, because we luckily have one already done, which is also a very clean code, not gonna lie. What happens anywhere here? So what you have here on top is called a using statement. That is an import. This literally tells our compiler, which is a program that will translate this human written language into ones and zeros for the computer to understand and to execute. So in that case, we need the system collections, which is literally just a collection of different stuff that the system can produce, like math, vectors, stuff like that. Then we have the generic class on top of that, the framework, which makes a general type of stuff. If you want a more technical explanation for that, we can do that, but then we'll probably have like a 5-hour lecture that I will hold right now. So we skip over that. Just think about it as if you have numbers that have special values like an integer, which I'll explain later on, or a float. And then you have like a generic type, which is like just a T, which can be anything and everything you want. It's the ditto of programming. I think that is the best short explanation I can give. So then we have the Unity engine import, which is specific stuff like a game object, like the sound controller, like all the stuff that is specifically only made for Unity, so we can use it in our code, and the compiler understands what it is because all the references for it, which is like a dictionary, is here. Same goes for the UI. It's everything we need for the user interface. Then this is something that is specific for C# and how you word it, because other things is pretty much like you can interchange it with like different programming languages like Java or C++. This is a specific statement that says if we have enable input system, which is an option in Unity, which you can find when you go into here, edit, project settings, and then you have the input system right here. So it asks, is this enabled when we start the code? And if so, it also should use the Unity engine.input system library, which gives all the references to how we can control a character. That is just like the top of here. The rest will be a bit quicker because there's a lot of repetition in there. So the next thing is we have the class declaration. The class is called simple FP controller, which is gonna be used to reference it across anything in the project with that name. It's a name that can only be given once. It's a unique name. If you do multiple ones with the same name, the compiler and Unity will start crying like little cunts and go like, oh no, you cannot do that. We already have that name there. Just remember, guys, classes, which are just pieces of code, need to have a unique name. And then there comes a specific for Unity, which is mono behavior. So in C#, guys, damn, now I need to actually throw a bit of a lecture anyways. Let me quickly find a picture for you guys to explain the concept of object orientation and inheritance, which I think this one is doing a perfect job for. I hope you guys can see it. So what you're seeing here is how inheritance can be explained pretty easily. So imagine you have a piece of code. That one can inherit, so take over all the methods, all the values that are assigned in the other one, and make it their own, and build upon that. So for example, if we make a basic class called animal, that one can then be inherited by a different script. Let's say we have a dog. Let's actually make a practical example because I think that is easier. We'll quickly generate a script which we call animal, and we open that up just so you guys can see. We don't need any of this. We don't care. We also don't need this for now. So we have an animal now, and we're gonna declare that the animal has certain things, right? Like an animal has probably an int, which is just an integer. It's a number without comma separation. And that is called like leg amount. And then you can see there is like auto completion. We just take that. So we now have that an animal has a leg amount, a name, an age, a color, a gender, a species, a habitat. Actually, for the sake of that example, we'll take species out. We have that. So there can be different animals, right? Like animal on general is like a broad topic. But what about we also have another script that is called a dog? So what we would do now is, if we are not good at programming, which we are not, but we glance over that, we can say it should inherit from animal, which makes everything that we have in here accessible in here. So we could say leg amount equals 4. The name is Jimbo. It's a brown colored dog. It's 1 year old. Species is a dog. I don't know why he put species over, because species is not accessible anymore. Its habitat is a doghouse and he eats dog food. That saved us a lot of time, didn't it? So to make stuff now make sense in that scenario, what happens here is mono behavior is a big compilation of stuff that is Unity specific, that makes the world go around basically, which gives us stuff like vector 2s, which gives us stuff like the camera as well, which gives us all those things like keys, key codes, game objects, which come from either the Unity engine UI, the input system, or mono behavior directly. Every script you want to use in Unity needs to use mono behavior as their base class. So just to go back to the animal explanation, it uses mono behavior right here, right? So if dog inherits from animal, An animal inherited from mono behavior, dog also automatically inherits everything from mono behavior. This is like hierarchical inheritance. If that doesn't make a lot of sense to you now, it will be later on, because we actually will build an inheritance for all the enemies. But just so you know, with an easier example, that is how inheritance work. Now we can delete both of them because we don't need them actually. Also because it will throw an error because we didn't make it clean. And every time you delete or add stuff into Unity, it will actually reload everything because it's checking if everything works. Okay, let's go back to the code. So, this is called a header, which is literally a fancy way of saying it's a title. It also makes stuff sorted in a different way. If you have a header here, this will be in Unity like a separate point here. So imagine we put it on there on something. It's going to be like camera has a header here. Then the next point in the menu is going to be whatever is the next point here. So how that works is this one here is a public vector2. A vector2 means we only have the x and the y axis. We don't have the z axis available. This is literally a force we can apply to an object. In that case, it's the mouse look, which means it's for the camera, which means we can control how fast the camera, what force the camera is going to move when we move the mouse left and right, or up and down. This is the mouse sensitivity, the vertical look limit. That basically means there is a limit on how much we can tilt our head. For example, you cannot put our head higher than this. And we can also not turn it 360 around. In that case, there is no 360 limitation because you could be turning yourself around, not just your head. And then there is something interesting, which I really like about that code, just looking at it the first time. It's a smoothing effect, which makes it so that there is no stuttering if you go like this, but it's going smooth like this. This is just a small extra force applied to everything here, probably later down. Just to explain it, a float. There are different number values you can assign to something. The most prevalent you will see in Unity is a float. It is a comma-separated number, which can have up to, I think, 4 or 6 points behind the comma to be really usable in Unity. There are 2 more types that are often used. One is an int, which is just a number. No commas, no points, no nothing. It's just gonna be a number, like 1, 2, 3. Then you have doubles. Those are comma-separated numbers. Those can be like 0.5, 2.76. They have a smaller range than floats, and then you have floats. Floats are used because they have the biggest, those are the ones you can calculate the best with. Like, they don't have a lot of overflow, they don't round as much, they are pretty precise to use. Those are the 3 ones you should know. There's also one more type, which we'll come to soon, which is a Boolean, which is just a simple yes or no. This is very often used to flag game states, to make certain assumptions. Just to put it in a perspective and give you a general example of what you would use each of those 3 number types for. For example, you would use an int for something like experience points, because you wouldn't want the player to run around like with 15.76892 experience points, right? You want them to have like 10 experience, 25 experience. To erase difficulties in calculation, you would just use an int for that. Also player levels, level count. Most likely you would use an int for that. What you would use doubles for is mostly stuff like currencies. Because you don't want more than 2 points behind the comma, which is usually the limitation of a double. So you have like basically $10.99. That is what you would use a double most likely for. A float is for anything that requires complex calculations, like a float where you want to talk about the speed. Just to put it into perspective, if we hover over here. Okay, it doesn't show us, but usually a vector 2, or any vector, is going to be operated on floats. Even though they are like complete numbers, like an int, those are floats, most likely. Okay, let's jump to the next one. There is a public float that has no value assigned to it. You can do that and not assign a value to anything because the value is assigned later. This is called an initialization without a value. And what it does is it just gives us a name to reference later, which is the X rotation. And then there is something that is Unity specific again, which is we have a camera, cam named, that is the name of the camera. And that is like where we can put the camera to control the first person camera. So when we put this whole script onto a object, we can assign the camera that is in our hierarchy in the scene to be that camera. And we can control it. So next is the movement part. There is pretty much not much to say about that. So we have a Boolean. A Boolean, like I said, is literally a true or false statement, which is nothing more than saying yes, there is, or no, there isn't. So in this case, there is a physics controller, which is false, because usually you wouldn't put in a physics controller in most games, except if they are really heavily physics driven. Otherwise, you would most likely calculate everything with floats. We have a walk speed, which is also a float, even though it's a full number. Because there could be like some kind of calculations which increase our speed by 0.5 for whatever reason. Like going up down the stairs 0.5 more, going up the stairs 0.5 less. Makes it easier to calculate with. So that is the walk speed, which is just 1, which is a base value. Then we have a run speed, which is 3. So we get a multiplier by 3 to run. Then there is this one, just for your interest, if you put 2 of those in front of any line of code, like this, you comment them. You can place comments everywhere in your code to make stuff more readable. Like for example, we just put it in here, this is a test. What happens is comments are ignored when it's compiled. Like those disappear completely. The program doesn't care for them when it runs. It's just for us humans to make the code readable. You would use them if you work in a team or if you want to make a node for yourself. So in that case, there is potentially a jump force built in here, which means there is a jump functionality built into the script. But it's not used currently because could be that when you play this demo scene, you don't want to jump. Actually, in our game, we probably don't want to give the player the ability to jump. So that it's not in the game actually is what we want. And then we have the private float speed, which is literally the same as the walk speed. We will probably see later down when we dissect this code to the end and explain everything so you guys have a basic understanding of how code works. What it does. But right now it's literally the same as the walk speed. It's probably used for something later. So we come across this again. And for the keen-eyed viewers upon you, you see it's the same one as here. This is like, again, a specific thing in C# where you can execute script or don't execute script if there is a certain Boolean value, which this is nothing else than a normal Boolean, which tells you, is it true, is it false, yes or no. This is for the controls, which is literally just, okay, we have a functionality that says public key forward So we have a key assigned already for moving forward, which is the W key. There's also a key for backwards and so on and so forth. This is literally your standard button layout that you want. And why is it doubled in here, if you can see? That is pretty simple. One uses the input system that Unity gives since like a couple versions. And one is if you don't use it. Because then instead of using key W, key S, key A, you use the key codes that are provided by your keyboard. Those come from system collections, by the way. Those here. Those here come from the Unity engine. More specific, the Unity engine input system. It's not very complex. It sounds more complex than it is. It's literally just like, how do we get the keys or the key codes? And which of the two are we using? So you see here an if. And if it's enable the input system, then we use this. If this is not the case, it's where the else comes in. It's a normal statement in programming that you use if else's. For example, like you check if something is true, do that. Otherwise, just do the other thing. That is what we do here, and you need to end it on an end if. Otherwise, it thinks everything below here to the end would be only in the code if that is not true. Just a reminder, you need an if, else, and end if you want to make code executable on the premise of something being there or not. So then we have a site, which probably this is only for shooters. And only then it's interesting because that is, do we have a site? No. And also, do we give a game object of the site prefab? No. A prefab, like I said before already, is a pretty much pre-made thing for Unity that you can create yourself and reuse. A site in that case would be like a holo visor or like a gun point that you look down. It belongs into basic FPS games most of the time. Yeah, and also there is a private rigid body RB. A rigid body is for having collision detection, having gravity work on your character and stuff like that. We'll get into that later, probably next stream if I look at the clock, when we start doing stuff in the game. Because this was a very theoretical heavy stream, I'll admit that. I hope you guys still enjoyed it, but we'll get into a rigid body later on and the specifics about it. But just think about it. It's an actually body you give the game to work with, which is subject to collisions, which is subject to gravity, which is subject to being constrained. For example, it cannot move in the XYZ direction, or it can move in the XYZ direction. Okay, so next thing is another Boolean. Those are literally just states that we have. In that case, a state, imagine it like, are you poisoned or not? Yes or no. Are you sleeping or not? Yes or no. Are you hungry or not? Yes or no. Those are states which are usually controlled by a Boolean. Which gets me to, we should probably explain public and private in front of stuff. Sorry if I'm jumping back and forth, but I'm not a professor on programming, and to understand code, you need to at least get like some level of it. Public means we can access that on literally any piece of code that tries to access it. Like we could go and say like, okay, on the script enemy movement, we could go like, okay, reference simple FP controller dot hide cursor and set it to truth. That would make the cursor, the mouse cursor appear on the screen of the player, and it would not be controlled by this script, but by another one. If it's a private key, variable or method though, it can only be called by this thing itself. So if we want to access it from outside this class, we can't. There are tricks to do it, yes, but generally we can't. This is called safety measures or privacy settings for code pieces. You don't want anything that isn't necessarily needed outside of the class to be public. Everything that is just needed for the class you want to set private. This adds a safety layer for yourself to not make mistakes, program bugs in, or anything that you don't want. Okay, next step is, and then we're coming into the beefier stuff, guys. Another specific for Unity, which is a character controller. A character controller is a piece of code that lets us get control over the character. And this is literally, I didn't explain that before, but let me explain it now. This is how you do it. If you want to get anything into the game, you set either private or public. Then you go and say what type you want. For example, you want a bool. For example, you want a double, a float, or something Unity specific like the character controller. And then you give it a name, because that is how you reference it later in the code. Got that? Cool. So that gets us to the first thing that is new for us now, which is called a method or a function. I think it's actually called a function in C#. In Java, you would call it a method. In JavaScript, you would call it a function again. Actually, when I think about it, I think you call it a member in C#. Doesn't matter. Same name, a different name, same thing. So what it does is, on disable, which is if we disable something that is a built-in function call for Unity, we set the cursor visibility to true. Which means, okay, if we disable whatever is called on here, we can see the cursor again. If not, if it's enabled, it's not there. Okay, which brings us to the next Unity specific thing, which is void start. This is called at the start of the game, or whenever the scene is started to load. So for example, if you press start the game and the main game loads, this piece of code will be executed. You can still call it method? Okay, perfect. Everyone now knows different names for it though, which is fine. You learned something today. So at the start of the game, every time this gets executed once. And it is only when this thing comes into life. For a controller, it will be alive in the moment we start the game. Which does the following. It gives the controller a component, which is the character controller, which is defined here, which we will define in the hierarchy later on. Then it will also give us the camera. This will assign the camera, which again we can put in the hierarchy and in the inspector to the object, so it finds it. So this is literally just called a reference, and it helps the game and the program know what we want to control with it. So we would put the character controller on the model of the character to move him around physically, and we would put the camera on the cam to move the camera around with our mouse. Pretty simple. I think so as well. So this one here is an if statement you saw already on here, but this time in code and not in like a assembly reference. It's called hide cursor. So it checks if the Boolean hide cursor is true, we will set the cursor visibility to false, which means we don't see the cursor anymore. And we also lock the cursor in the middle of the screen or wherever it was, so we don't accidentally move the cursor to the side outside of the window if we are in window mode, and minimize the window on the first left click. There you have it, guys. Someone more knowledgeable. Learn that. Remember that it will be on the test next week that you all need to do in order to watch further. So, what happens now though if this one is not true? And we don't want the cursor to be hidden. Then we will have the cursor visible again because we set the visibility to true. So can we see the cursor? Yes. And it also removes the cursor lock, which is this one. Cursor lock mode dot locked. This means it stays in place. Cursor lock mode none means we can move it around. We go over this quickly because it's a site and we don't care for that. It's literally the same thing as up here, but for a site, and we can transform it to see where it moves. Don't interested in that. That gets us to the next thing though, which is also Unity specific again, which is called void update. The update function, and that is very important for Unity, guys, because that is, for example, why 30 FPS makes the hacking game in that signal doable compared to when it's not, it's impossible. The update function is called on every frame. So, if we don't put constraints in, the game will update more often or less often depending on the FPS you have. That is an oversight Adam did in his games quite often, where, for example, you remember that spinning game when you try to hack something in that signal, right? So if you have a high count of FPS, it's going like crazy. That is because the update function for moving around that little piece of where you need to click is tied to the update function. And he didn't put a lock in to prevent it going too fast if you have high FPS. It's a common oversight, happens in a multitude of games. Bad for him. It's the first game that I remembered right now. So what it does is it updates every frame. So if we put positionings or anything to that, people with higher FPS will have a faster game. People with lower FPS will actually have a slower game. And it's not just a little bit slower, it's insane. That's why you don't put important updates for a lot of stuff in the update function, and you need to rewrite a new one, which gets updated based on the physics. We will probably not get to that because that is also super deep into it. Just, it's a fun fact to tell your friends, right? Knowing like, oh yeah, by the way, this game behaves differently on different FPS because of the update function in Unity. Enough of that. Sorry for getting carried away. There are literally two things in there. Because if it checks everything every time a frame is updated, we can call functions in here and see if they are executed or execute them and also work with them then in real time. For example, you see here we have the camera look function. This is down here. We already know that all of this we can pretty much ignore because it's just like if the mouse moves in different types of talking. What is important though is now down here, which is the calculations, which look far more complex, but I promise you guys, even I can understand it, so it's not that hard, for how to behave when you do that. So we have the X rotation minus equals the mouse Y. That is literally the rotation on the X-axis is the same thing as when we move it on the Y-axis. But we subtract the minus axis before that. So it's literally like if you would write it like xrot minus mouse y equals xrot. Nothing more. That is just a shorter way of writing it. So now you know. Okay, so after that, we do a operation which uses the X rotation, the vertical look limit as a constraint, and the vertical look limit on the Y-axis. If you guys remember, up here, we only have a vertical look limit, so that one is literally not important for us. It will just be a 0, it will be overlooked, it doesn't matter. This is just like we have the X rotation, which also is determined by how far we can go by the other limitations. Then we put the smoothing in on both axes, which is literally just to make the camera movement be slow. And then we have the transform, which means, okay, by that amount on the X rotation, you will move the camera on the X rotation every time we move it. The transform is used here as a local Euler angles, which is declared somewhere. But it's literally just like the rotation of the camera on the x-axis. Then we have the rotate on the y-axis. It's a rotate in that case, not like the complex thing that they use here, because it's literally just rotating the camera and not changing the position of the camera. They probably use the Euler angles here because you want to move the camera a little bit and not just have it stand in place and rotate, because that could cause clipping into the back of the head of the character model and stuff like that. And you also want to move the camera with the model. So why did I explain all of that? Easy and simple. This checks non-stop if one of those axes moves the mouse on, which then gets called in the update function. So literally every frame we have, the game checks is there movement on any of the mouse axes. If there is, it's gonna perform that calculation to determine if it needs to move the camera left, right, up, or down. That's basically it. We have the same thing here, just a little bit more complex, for the game player movement. And I promise you guys we're nearly done, and then you guys can enjoy your evening and pretend you never had to listen to a whole class of how does programming work, which also was on a far higher level than any lecture you will see in university. So we have the player movement thing now, which has different states. So yes or no's, which is again, is the button pressed? That is nothing else than checking for Boolean a yes or no answer for do we press a button currently, which in that case is the run button, which was earlier determined to be the shift key. So you see that it's all coming back and together now. So if we are pressing the run button, our speed, which is 1, gets increased to 3. So that's why they used speed. It's the current value. Would have done it a little bit different. I would just not use speed. I would just use the current speeds every time. But that's fine. It's a lot cleaner than I would have done it. So yeah, it sets our player speed, which is the speed stat, to the run speed, which was 3 instead of 1. If it's not pressed, it goes back to 1. Pretty simple, right? We have a state of sprinting, not sprinting. Speed is different in both kind of ways, gives the player a feel of movement. So the next one is, are we pressing the forward button, which we determined is W? If yes, move forward move equals true. This again is for the input system, which then assigns the variables of move left, right, up, and down. It's a lot easier if you know how it works. It's it has a quite steep learning curve, but once you can use it, it's very good and much faster to prototype any type of movement. The same goes for forward, backwards, left, right. Pretty simple stuff. So, but what happens now if we don't have that input system? Because then we kind of need to know what to do, which is coming down here. It also gets called up here, but to be fair, we wouldn't need that amount of code. We could also do that in the GUI, which is the graphical user interface, which means in the Unity thing itself. So it's the same thing, just a different name for everything. It's input, get key, run. So input means is a button pressed, get the key means which key do we want, and run means it's a shift key because we assigned that variable over there. The same thing for everything else. Forward, backwards, left, right. And now we have the fixed updates. Those are the ones that are not prone to being weird when the FPS are high, because they have, like it says, a fixed time when they update. So this, again, Unity specific, but not prone to error or weird behavior once you have like a trillion FPS, because your game is not graphically advanced enough to get a 50, 90 to sweat even a little bit. So what it does is it gives us, if forward move is true, which is true if we press one of those buttons, transform the player on the forward axis, which is going ahead, with the speed times 0.01 f, which makes sense only if you know the size of and the scale of the map. In that case, this belongs to the map I showed you earlier. It works fine perfectly as well. Same goes for backwards, but it gives us the minus speed. Why does it give us the minus speed? It just moves us backwards. So literally what you want to do here is, like, if you want to go forward, you use the speed you have and go forward. If you want to go backwards, you just reverse it, so you get negative speed. So imagine it being like a car going in reverse. It would be the same speed that is shown on the tempo thing, but it would go backwards. It's literally like that. Simple math. Same goes for left. Left is minus speed on the left, on the right transform. You see there, it's forward transform always. It's a little bit confusing, I'll give you that, but it makes sense because everything in here is a mathematical calculation for what it needs to do. And then you have right move, which is the positive of speed on the right scale. And now there is something that is really interesting, because that one is needed for jumping. Usually when you want to make jumping available in a game, you want to check, is the player on the ground? Otherwise he cannot jump. You cannot jump in the air, right? So you want to check, is the player hitting the ground? That is just literally a check. Is he on the ground? Yes or no, and return whatever the value is. It's not going further because we don't have jumping in that script right now. That leads us to the last thing, which I actually need to look at what it is. It's a physics sphere cast, so that is literally a physics thing from Unity that casts a sphere around the visual we have. Around the controller, actually, because it uses a controller. And the raycast is literally a camera thing where is the camera having it in its view, and like imagine the camera casts like light rays out. Whatever it sees is getting hit by the raycast. Gives us a hit info that is used for... Okay, so this thing is used for collision detection. Don't know why I didn't see it in the beginning. It's a weird way of doing it. It's a very convoluted way, but it's probably also a very good way of doing that. What it does is it transforms our position by calculating the controller radius. It transforms us up and down based on whatever the raycast hits, and it literally does that by ignoring stuff or not. What it actually does is, because this is literally just a convoluted way of saying, are we hitting something? It keeps us in place and makes us not walk through stuff that we shouldn't walk through. Like we explained in the beginning with the table that has a collider, we cannot move through that. That is literally all it does. It's a fun thing to know. It's a convoluted way. You will see colliders are a nightmare to work with, but that's it. And just like that, guys, you got like a round slap of all the coding you actually need to know in order to make a video game, because literally everything else is just building on top of there. And coding isn't that hard. It's just the number of its pieces that make it hard, because you need to think about a lot of bullshit. But yeah, so that also brings us to the end of today's lecture. Yeah, that brings us to the end of the stream for tonight. It's been 3 hours. I've been My head is actually smoking right now. Because that was a lot of thinking, a lot of explaining, a lot of stuff I usually wouldn't think about in my normal day-to-day life as a software developer and consultant. But yeah, what I will do till next week is I'm gonna try to get a little bit of coding done, a little bit of back work, so we actually get the project moving, and then we'll do like in the first half of the stream, probably I will go through, show you guys, explain to you guys what the thought process was, what we worked on, what I did, and then we're gonna work on that further in the stream next time. I think that is a good idea. We will talk about design decisions, about stuff that goes in, about like difficulties I had, all that kind of stuff, to get you guys also more into getting into the game development. Like maybe you guys then want to try and learn stuff about coding and stuff. That would make me very happy if I intrigued your interest in that. But yeah, until then, we'll go off. Tomorrow is Variety Day. I have no idea what we play. Maybe we'll play the Digimon Time Strangers demo because that dropped today and I'm pretty hyped about that one. Maybe we play some random bullshit. Maybe we also just go back to Pokemon because I think everyone had a blast yesterday doing that. Before we killed the fun with going into game development and how to read code. But yeah, until tomorrow, I wish you all a good night. Love you all. Thank you all for hanging out with me tonight and suffering through this lecture with me. It means a lot to me that you guys watch. And like I said, love you all. See you tomorrow. Bye bye.